You did well, but kudos to you. I like it. You had a pretty weekend, right? Calculus. All right, I'm gonna come around and check, and we're gonna talk about some stuff. Yeah. Good. How did it go over here? Yeah. Guys, how we looking? What's it? Good. Well, let's get on it then. How come I didn't see you before school then, so we can clarify
I
something?
can undo them. Oh, because
You're confused? Oh well, right? Oh well, nothing I can do about it. Before class, get it done. The time is this class is too valuable. Come before. If you guys get confused on it, put more so you can like reference it back. You know what I'm saying? Okay. Where have you been working? Check you guys out. It's all online. We tell her it's all online. No it's online.
for 15 years, I got the
All right. Okay, so you guys, I'm just going to read these off. We'll go through these real quick. You guys ready? One, from the left side is 0, right side is 1. So it's not differentiable. Add 0. For 3, derivative from the left is 1/2. Derivative from the right is 2. Not differentiable. 5 is A is all points, B is none, C is none. 7 is all points. Hold on. All points except x equals 0. B is none, C is x equals 0. 9 is all points except x equals 0. B is x equals 0 and C is none. 11, it has a discontinuity because the limit value doesn't equal the function value at 0. 13, limit from the left is 0, the right is 2, so it's got a corner there, not differentiable. And 15, limit from the left is 5, limit from the right is 1, so it's got a corner. Since the derivative from the left does not equal the derivative from the right, the problem is not differentiable at that point. Yes?
For like 5 through 9, how is it differentiable at an endpoint?
What does the definition say in the book? I think they should define it too. Who's got a book? Look it up. I think it's another thing where it's like two different definitions where like continuous at a point and continuous at an endpoint. Check it out. Hey guys, what we're going to get into again today is like the difference between differentiability and continuity and all these different things. Okay, Eleanor? Those are the two big things that we're going to start building together, and it's going to turn into a big mucky mess unless we can start like putting everything in its little corner. Okay? Here's what I mean. Let's look at number 1. What was the fun one? It was a little shark fin. This was x squared and x, right? Yes? Okay. What's the limit as x approaches 0 from the left? All peepers up here. What did it say? David?
It said that as long as it's approaching, like the limit.
From 1 one side.
The endpoint, yeah.
So one-handed again. What's the limit as x approaches 0 from the left? 0. What's the limit as x approaches 0 from the right? Why is it also 0? What am I asking? Let's call this whole thing f of x. Limit as x approaches 0 from the left of this function equals 0. What is that question asking?
The value is
What? Yeah.
What is f of x as x approaches 0?
When x approaches 0, what does the y value approach? From the left. And that is what in this case? 0. Yes. What's the limit as x approaches 0 from the right?
0.
As x gets closer to 0 from the right, what is the y value approach? We're going to talk about what you're talking about next. The y value also approaches 0. What does that mean about the limit as x approaches 0? Since the limit from the left equals the limit from the right, the limit exists and it's equal to that value. The limit as x approaches 0 is equal to 0. What is f of 0? What does that mean in terms of continuity? Why is this function continuous at x equals 0? Say it.
Because the function value is equal to the
Yeah. Since the function value equals the limit value, the function is continuous at that point. That's the first thing you should check. If you're looking at differentiable at a point, first thing you need to check is if it's continuous. Because if it's not, game over. Does that make sense? This one is. Limit from the left equals this little upside down shark fin. Limit from the left equals the limit from the right equals the function value. So this is continuous at this point. Now, how do I figure out, let's say on our calculator, whoever did it on the calculator, what the derivative is as x approaches 0 from the left? How would you figure that out? And how would you figure out the limit as x approaches 0 from the right? How do you do that? How? How? So get your calculators out. Talk to the group. Calculators out. Ask the questions. Get in the game. How do you figure it out? If you don't know, say, I don't know. What are you thinking? How do you figure out what the derivative is from the left at x equals 0? You could do it piecewise, and I'm going to get to that sign. Like that's actually going to be an interesting way to do it. Any other ways to do it before we get into the piecewise? Find the derivative at 0 for this weird thing. If from the left it's the x squared function, and from the right it's the x function, you could do that and do it all by hand. What I ask is, how can you use your calculator? Since this section introduced all the calculator functions, how can you do it to find that derivative from the left and from the right? Yeah?
Go to math and then press 8, and then put in the equation, or the function.
What's the whole piecewise, like Sonia said?
No, just the one from, if you're going to start from the left, put the one from the left.
I see what you're saying. So if you want to know the derivative from the left, just graph the x